Hello, everyone. I'm SK Cha, co-founder, CTO of HCS in Korea, and which I supply. We are supply solution to the smart factory today. I'm gonna explain about the title, moving from traditional to make a factory. Before starting, I'd like to introduce the HCS first. HCS have been success complete more than 1,500 projects that started from Hyundai Motor for assembly line and Postcard for real-time monitoring production management and Slavia automation since its established in 1988. HCS several certificate. Also, we have some certificate from Korean government, and we have a global international R&D project, including Eureka in Europe, etc. So, okay, I have four topics of agenda today, sharing information today as first, manufacturing environment change. Second, smart factory in Korea. Third, smart factory project for dyeing process in the textile industry. And last, I'm gonna sharing with future factory model. Okay, as you can see the slide as is and to be, manufacturing environment rapidly change as after Corona. From mass production to personalized production that we call mass customization. That means production line must be changed, the autonomous distribution process for company survival. But our reality is not still manufacturing doing manual operation due to the save costs, and it's not easy to replace with a high expensive automation system using a robot, etc. As you mentioned, both a German very famous auto part manufacturer and the automation solution company mentioned more than 70% of legacy machine still not connected. However, manufacturing company must think about to be or not to be. That's a problem. For to be, we have to focus on a paradigm shift to high yield or productivity that provide horizontal integration as prognostic and decision support tool. Means that identify, capturing, sharing, and use that we call the data revolution in a post-industrial revolution. Another things comes is a new emerging information technology such as IIoT, industrial Internet of Things, and 5G involving architecture of a manufacturing system. Left side of slide of ISO 95 function was a traditional method of standard of manufacturing IT since the last 20 years. That I have been involved. But it will be changed a lot of data integration model of local real-time control. Already allow show up the new system computation as well. We call the edge or cloud computing that I'm currently involved in developing now with United States. You will get sooner or later. I would like to a little bit about how it works. We can divide the two worlds as cyber and physical IT people said, that is CPS or digital twin. I also developed a TTA, Korean standard, for a guide to smart factory area that will be expanding ISO International Standard Organization standard in near future. For integration of production resource data, must considering standard for making a common sense that talk the same word or same rule. Here is some important standard that we have to considering implementation for smart factory in all of manufacturing IT area. Interesting, German and the United States struggle to reach same factory, smart factory standardization model. ISO is promoting common standard until 2022, but progress is not easy. Manufacturing factories remotely distributed around the world can be integrated through the CPS, cyber physical system. Therefore, COVID-19 enables online management without visiting overseas plant. That's provide the cyber physical system, provide online against the risk of COVID-19. Because of today, we are providing online conference in here. I would like to explain about the smart manufacturing deployment phase in Korea. We have Korean government look at the three phase from 2014 to the 2019 as last year. We focus on supply and the diffusion of smart factories. From this year, we built a database, cloud, big data, DNA platform that can be store and analyze of production, manufacturing dynamic data. And 3 years later, from 2022, we will be starting high performance computing DNA platform to first move of fourth industrial revolution. That is main goal of is we focus on G4 in global manufacturing. And next phase one is 30,000 of 60,000 SMB has been involved by year 2022. And upgrade more than 25% of level 3 and 7,500 companies to collect and store manufacturing data into the see our slider. Execution of phase one focus on automatic or waiver incentive industry like assembly line into the smart factory. From factory automation to the autonomous production system, focus on customer requirements of buying a building for technology like IIoT, artificial intelligence, AR, VR, 3D modeling, 3D printing, drone and robotic, and digital twin. As I mentioned before, POEM 2E, data management most important portion in smart manufacturing. Phase two focus on cloud data center. As you show, we are think about starting this year. More than 200 companies supporting, as you can see the slide. Phase three of a big picture, HPC, high performance computing based artificial intelligence cloud data center expansion and utilization, so that constantly building manufacturing specific AI could data center linked to public cloud, including Google, Acer, Amazon, etc. And the group company as POSCO, and Samsung, Hyundai, and LG. We provide the manufacturing company operation on a platform supporting various prediction based on infrastructure as a service or platform as a service and software as a service platform that connect to the sensor and device through the edge gateway. To this end, it is planned specialized in each industry and manage common data horizontally. In the end, it will provide an efficiency system for involving quality, reduce cost, and reduce the delivery time, strength in competitiveness of the manufacturing industry. Next slide, I'm gonna explain about the construction of the smart factory for dyeing process in the textile industry. We have, as you can see, we started July 2019 to the December 2022 for 2.5 years. R&D budget, we have $70 million US. Total 9 organizations involved research and development consist of three as ACs. We had our project, 2 textile machine manufacturing, and 2 users as a large and small company, and 3 government institutions. Smart factory status of a dyeing factory in Korea. As I mentioned before, the smart factory level, we divide into the 5 categories from level 1 to 5. Most of the dyeing manufacturing enterprise in Korea is less than 50 employees. Mostly ICT does not apply as level 0. As shown in picture to the right side of the slide, ACS has been successfully deployed global dyeing in Hanseol Textile in Vietnam for last 2 years. Smart factory level 1 to 2.3. Okay, here is a company, global dyeing company in Vietnam. Global manufacturing based on Vietnam, Cambodia, Indonesia, Guatemala, and Nicaragua, producing more than 37 million pieces of clothing per month, operation at 3 million kilograms of fabric per month in Vietnam. Global dyeing and global Huntex increased sales 200 times over past 20 years. This slide shows overall system configuration. Mainly of MES manufacturing execution system consists of major 5 functions as lab management, process management, maintenance management, and quality management, including SPC and SQC, and real-time integration of manufacturing data of POM money integration in real time, and integration with other IT systems, including ERP, time and attendance, and outsourcing and warehouse management. This is how integration production. We have major 4 manufacturing area. We hook up all of production and device and material and everything through the gateway. Next slide, I would like to show you vision and strategy of Made in Korea for G4. In Korean government, textiles used the rise of added value of flagship industry to the world highest level. In this field of clothing, the production innovation, smart pilot plant was selected and announced manufacturing opportunity and innovation strategy in 2019. Here is a scope of R&D and goal. We have one goal of productivity as increase at least 50% of quality, overall equipment effectiveness and productivity. And five core technology developing. One is POEM, one is data integration through the IIoT and edge computing. And we apply to based on international standard, industrial data application. Also, for digital twin, we are using a 3D visualization. Also, last thing, we have quality production using industrial artificial intelligence. IIoT into dyeing machine with edge computing. As you can see, we put on adding new sensor in a dyeing machine. Also, we put on IIoT in a dyeing machine in a gateway. So we are able to see real-time dyeing works data as temperature, pressure, loader pressure, material speed, and energy, and run and no time data by real time. So we are able to bidirectional control in real time between dyeing machine and dyeing process control in locally. It is very interesting. We try to developing with Korean government institution. Next one is IIoT into the tender with edge computing. We put on several special sensor as three type. One is density of a feed, stripping control. And second is optimal heat, temperature control, and humidity control. That means we can locally control the tender in real time. Another thing is IoT into the sewing machine with current transducer with high density camera or with industrial AI. As a matter of fact, current transducer is easy to install in inlet of power. Then we are able to collect data of runtime of sewing machine. As a matter of fact, the sewing machine is a very expensive, not expensive machine, so we cannot spend a lot of money for sensing collection. So this is a very good idea. Another good thing was we tried to making autonomous configuration because we have autonomous auto configuration can be covered easy to reconfiguration of work center in a factory area. This is various robotic into the textile industry for unmanned. One is bobbing, dissolve process, yarn test and inspection process, public roll transfer process, fabric roll transfer process, leather transfer process. That means 3D works, so we can try to making a unmanned system. Last chart agenda, I'm going to introducing about the future factory focus on, as a matter of fact, industrial AI is more accuracy, curved, optimal system. compare with AI and machine learning, export system, and export experience. As you can see the bottom side of the slide. So we are able to unknown knowledge for smart information using value creation through the number 3 to moving to 4 as twin model and the CPS. So you can see that we can see the platform technology, data technology, analytic technology, operation technology, all of a combination through the industrial AI makes optimal system in the future. So we are focused on RAMI. RAMI means German standard. We focus on AAS, Asset Administration Standard for Power Project. Dying and electronics industry of maybe April to the December. That is a very interesting. We are focused on a future model in dying office. Okay, thanks to listen.